To understand the true power behind the King of Curses, Sukuna'S flame arrow in Jujutsu Kaisen, it is important to first understand certain fundamentals of destruction and physics. To get a proper sense of scale, we are going to analyze fragments of the explosion where we can extract visual references. The fight against Mahoraga in Shibuya helps us quantify Sukuna'S destructive power. We are going to examine the size of the explosion and the behavior of the fire. If we take the flame height as a reference, we can see that it rises far above what appears to be a building roughly 30 stories tall. Taking this into account, and assuming an average skyscraper floor height in Tokyo of 3.5 meters per level, we can estimate the building's height to be approximately 105 meters. Now the key question is, what visual proportion does the flame have compared to the building? The visible 16-story building occupies roughly the lower left third of the frame, while the fire column surpasses it considerably. Visually, the flame appears to be around 3 to 4 times taller than the entire building. So if we multiply an average factor of 3.5 times 105, we obtain 367.5. For the calculation, we will use an approximate flame height of 350 meters. Next, we estimate the destruction radius to cover about 5 urban blocks, and in Tokyo those blocks range between 80 and 120 meters each, giving us an estimated destruction radius of 400 meters. Next, we calculate the released explosion energy using the Hopkinson-Kranz scaling relation, dWHR cubed, where r is the blast radius and z = 2 for total destruction conditions. Solving the equation gives approximately 8,000 tons of TNT, comparable to slightly more than half the power of the Little Boy nuclear bomb dropped on Hiroshima. In terms of destruction, it is essentially as if Sukuna directly launched a tactical nuke at you. Now we calculate the total energy in joules. E = 8,000 times 4.184 times 10 circumflex 9, which gives approximately 33.5 terajoules, placing it within the range of a real tactical nuclear weapon. At this point, we have already deciphered the destructive scale of Sukuna'S arrow using analogies based on nuclear weapon scaling. However, another question remains. Why is there no visible shockwave? In the frames, buildings outside the explosion radius remain intact. The fire behaves almost like liquid flowing through the streets, and it seems as if the entire explosion is concentrated within only a few cubic meters before dissipating. This means it is not a conventional explosion. It is something potentially even more dangerous. So, what exactly is this behavior, and what is the closest real-world equivalent? The nearest concept in real physics would be magnetically confined plasma. It could be interpreted as a directed energy channel similar to a high-energy laser combined with controlled dissipation without lateral shockwave propagation. In other words, the energy does not spread radially like a bomb. Instead, it is funneled directly into the impact point, and then dissipates upward and through the streets as though it were following magnetic field lines. That is why buildings outside the direct trajectory survive. This makes the true power even more impressive, because concentrating the equivalent of 8,000 tons of TNT into a singular point without lateral dispersion is physically far more difficult, and more destructive at the impact point, than a nuclear bomb that disperses energy in all directions. In other words, Sukuna'S arrow channels all of its energy into a single vector, producing an energy density at the impact point that is theoretically infinite along the central axis. The Bennett relation, or Bennett-Pinch condition, describes the balance between plasma pressure and magnetic compression force. As long as this equilibrium remains stable, the plasma does not expand laterally. This equation defines the exact balance between the plasma's internal thermal pressure, which tries to expand it, and the confining magnetic force generated by the current itself, which compresses it inward. To put this into perspective, the following example involves a Lorentz plasma cannon with a final voltage of 240,000 volts. If we apply the electrostatic energy, it would require roughly 83.08 million times more power than that plasma cannon to achieve something capable of defeating Mahoraga. What we perceive as fire is therefore actually plasma undergoing progressive recombination, a conductive fluid with nearly zero viscosity following residual magnetic field lines in the same way water follows the slopes of terrain. Once the energy falls below the ionization threshold, approximately 10,000 Kelvin, electrons return to their nuclei, the plasma ceases to be plasma, and it disappears before our eyes without leaving radioactive residue, since no fission or fusion ever occurs as it does in nuclear weapons, even though the destructive power is comparable. In conclusion, Sukuna is technically environmentally friendly because he leaves behind no radiation, meaning the crater area could theoretically be rebuilt without dangerous radioactive exposure. And now we finally understand just how powerful and destructive Sukuna'S arrow would be in real life.